A single decision tree has a weakness: it's shaky. Change the data a little, and it can change a lot. But here's a beautiful fix, based on the wisdom of crowds. Instead of trusting one tree, we grow a whole forest of them, and let them vote. First, why is one tree risky? A single deep tree can carve a jagged, overfitted boundary. And it's unstable. Swap out just a few training points, and the whole tree can look completely different. We like the reliability of many opinions, not just one. So we build many trees, and we make each one a little different on purpose. Each tree is trained on its own random sample of the data, drawn with replacement. This is called bootstrapping. Every tree sees a slightly different slice of the customers. There's a second trick. At each split, a tree is only allowed to consider a random handful of the features. That stops every tree from leaning on the same one strong feature. The result: trees that are genuinely different from one another. Put those tricks together and you get a random forest, dozens, or even hundreds, of varied trees. No single tree is perfect. Each one makes its own mistakes on its own slice of the data. But that's exactly what we want. To classify a new applicant, we send them through every tree. Each tree casts a vote, repaid, or default. Then we simply count the votes, and the majority wins. That's the forest prediction. Why does voting help so much? Because the trees make different mistakes. One tree slips up here, another slips up there, but they rarely all err in the same place. When we average them, those random errors cancel out, and the good signal shines through. You can even see it. Each single tree draws a jagged, blocky boundary. But blend hundreds of them together, and those jagged edges smooth into one graceful, reliable boundary. The forest generalizes far better than any tree inside it. Random forests are a favorite for good reason. They're accurate, robust, and need very little tuning. The main cost: they're heavier to run than one tree, and you lose that simple, readable rule. You can't easily draw 100 trees on a whiteboard. In scikit-learn, a forest is just as easy to use as a single tree. We import the classifier and choose how many trees to grow, with n_estimators. Then the same fit and predict as always, and it builds all 100 trees for us. So a random forest grows many varied trees, different data, different features, and lets them vote. The crowd is steadier and more accurate than any single tree. Next, a different way to combine trees, not side by side, but one after another: boosting.